Howdy everyone, we are Team AccioSTAR and we will be your presenters. I'm Rotsi, I'm accompanied by Anish and Suraj. So just a fun fact, AccioSTAR is a name that was inspired from Harry Potter and cognitive systems engineering. It essentially translates to summoning safety, trustworthiness, accessibility, and reliability in complex systems. Before we introduce the system that we have been analyzing this semester, we'll briefly tell you why we chose the system in the first place. So the three of us live at three different apartment complexes here in Bryan Police Station with very different entry access systems. And surprisingly, none of these apartment complexes, they use the good old fashioned lock and key system, which we are so familiar with. We expected these keyless entry systems to be widely popular in the US, but a recent stat showed that most people here don't trust this system and have an option of keyed entry too. Now, this piqued our interest, and we wanted to investigate probable design and usability issues. And the opportunity kind of presented itself when we were kind of asked to do this project for ISEN 631. So, curtains up, we are introducing keyless smart access system for residential buildings. So, just kind of set this presentation, we will discuss our investigation findings by giving a brief introduction to the system, the cognitive task analysis methods that we have applied, and the data collection techniques and nuances that we have implemented. So once we have painted you the bigger picture, we will introduce some of the design problems and suggest solutions for some of these problems on the basis of implementation feasibility and novelty of the solution. Now, meanwhile, we will let you form your opinions and preferences and then conclude this presentation with your thoughts and our thoughts as well. Coming to the system introduction, our goals for the system are twofold. That is, we want the guests to securely self-admit themselves to the host's apartment through the front door. Firstly, in a state where they feel safe and have fun, because we are aiming this at maintaining emotional well-being and safety standards. And second, we as hosts, we want the guests or visitors to feel welcome and respected. Now, this second goal will help the guest seamlessly access host residence with minimum intervention and challenges. And like the underlying thing is that we don't want this to be a chore itself. Like it should be what we discussed in class, a pleasurable engagement when interacting with this particular system. And there should not be like a steep learning curve for this trivial kind of activity. And guests should feel comfortable and not overwhelmed.
Alright, for the system interactions, this keyless smart entry system has both hardware and software devices in the form of smart lock and a mobile application respectively that interacts via both offline and online connectivity tools like internet and Bluetooth. Encompassing this subsystem is a centralized management system along with security protocols that seamlessly integrate these hardware and software tools and technologies. But this is out of the scope of the study. We see interactions between environment, tools, and technologies. For instance, we see how sensor tools is widely used to alter and notify the users of any changes in the state of the smart system, which in this case could be successful authorization or door unlock subtasks. This could be achieved using sound sensors and haptic sensors, which are implemented due to relatively low cost when compared to visual sensors. Furthermore, we see interactions between tasks and contextual considerations. For instance, under bright light conditions, suspicious movements and activities of miscreants is expected to be limited, which may affect the decision making process of going with manual entry method since the visitor can take his or her time to enter as opposed to using the mobile application using Bluetooth in opposite scenario when it is dark outside and visibility is restricted, which implicates that cognitive state of the person might be elevated.
We employ two methods. First, observation and context via walkthroughs, and second, survey questionnaire. You might wonder why we leverage these two techniques, and here's the inside scoop. We wanted to gain a better understanding of the thought process and needs of different user groups when presented with different scenarios, which is why we collected primary data through contextual inquiry via walkthrough observations, as we felt this method would, for one, be unbiased, and for two, we would not be leading them and infiltrating their thought process. On the other hand, we circled back to survey responses to quantitatively validate some of our hypotheses and uncover general audience preferences so that we could prioritize problems and opportunities. Now, on to the interesting details of the observation and context method. We conducted walkthrough observations for 5 participants. One of the 5 participants was already familiar with the system and was given both options of unlocking the door a couple of days prior to the walkthrough, while others who were mostly unfamiliar with the system were divided equally, with one group given the door code access over a phone call and the other group had the code access through mobile application. Ultimately, the participants had the freedom to use whatever method they wanted. We tried to conduct this walkthrough as ecologically valid as possible and had two of the participants perform this task at night with a crowded corridor where we role played by non-mutual friends. And fun fact, the participants were not privy to this.
So, coming to the task description analysis, we took advantage of the hierarchical task analysis method to do our cognitive task analysis and understand the tasks performed by the users. Now, the objective of the study, which I have to kind of clarify is different from system goal, was firstly to understand the current system requirements for improved task interactions and interface design, and secondly to ensure that the system is working correctly and as intended with regards to safety and operability. Now, to achieve these two objectives of our project, we needed to understand the procedural flow, which we kind of call it as a user journey from the perspectives of both the visitor and the designers of the system. And we tried to identify this scope of execution and evaluation. Now, for this, we needed a way to define the goals means network in a hierarchical structure which the tasks will address. For instance, one of the tasks was how the user, performed decision-making activities once they reached the host's premises. Now, if we decompose this task further, what happens is first the guest becomes aware of the surrounding environment. Second, the guest decides to mentally kind of, premeditate which method to use to unlock the door, following safety standards. And third, the guest then proceeds to choose with one of those methods of unlocking the door, which could be like a door code access or, just using the mobile application and waving it in front of the smart lock device. Now, while doing this, a nuance that we had to be mindful of was the stopping rule. Basically, how many levels further should we decompose the tasks? Now, we had detailed parameters like task difficulty, predictability of events, frequency of system interactions, and some other 3 to 4 parameters, which informed us whether to stop the analysis at that particular task or activity. Long story short, we devised the stopping rule pre-task analysis with some, I would say, postulates. For example, we planned that for simple technological interactions, uh, the probability of failure multiplied by the cost of failure, if it was kind of acceptable, then that would indicate that we may need not, decompose the tasks or subtasks further. Secondly, we also decided that we would stop whenever the functional task allocation between the human operator and the machine would be dependent on human limitations or engineering design. And thirdly, we kind of wanted to, adequately address the system goal and make sure that the subtask or operation would address that and it would be self-deducible, basically. Now, understanding this design, like the task analysis, kind of helps us identify problems that broadly arise from three different, areas that we have identified. One is the operator knowledge or skills, second is the technological interactions and procedural tasks, and third is the user interface design. For the purpose of this particular project, we have kind of kept the engineering design out of scope. Now, you might wonder, like, how did we define the nature of these problems? And we kind of were kind of analyzing looking at cumbersome, error-prone, buggy mental models, biases, degrees of trust, and as you can see in the slide, we have taken some of these, the specific three of which we will talk about next. First, if we look at this particular portion, we observe decision paralysis when the guest premeditates the method to unlock the door. Now, a biased mental model we kind of see this biased mental model where if the door code is recently shared by the host to the visitor, even when the visitor has the option to use the mobile app, the visitor will be inclined to go with the door code method due to the recency and kind of because the host has already led the visitor to believe that maybe the door code option is the most efficient option when things could be otherwise. Secondly, since the mobile phone as a tool is used almost ubiquitously and is essentially an extension of our, I don't know, senses and is always handy, the mobile phone becomes something that is like something that we will always use. So what happens is it makes the user ditch the door code method, which otherwise would have been the most efficient option in a particular scenario. Moving on to the second one, we see that it is cumbersome and kind of prone to error every time guest enters the code manually on the touchpad of the physical smart lock. And just to clarify, it's like a 7-digit door code, and it's not a very, I would say, an ecologically sound design. The touchpad, which makes it difficult to interact with the system elements. Third, the guest succumbs to a buggy mental model, I would say, falling prey to the negative aspect of, wait for the term, it's called skeuomorphism, which I'll explain in a moment. But this happens when the guest or the visitor is contemplating which way to turn the knob or handle to unlock the secondary lock. I'll discuss, probably it might not be apparently understandable here from this slide, but I'll explain it in a moment. Um, by the way, the skeuomorphism, as I was telling, is an interesting term that we came across as a group, and it means that interface objects kind of mimic its real-world counterpart to facilitate transition to a new technology, which in our case it does entirely the opposite. So it does not work out. Well, let's start going deep into each of these three design issues by detailing the problems associated. So we'll start with the third problem that we have identified. So the top left side presents the scenario where the guest has entered the code or maybe has used the application for successful authorization, but then fails to unlock the door if the handle is turned in the wrong direction. Assuming that the purpose of the knob is unclear, or it could be that he or she knows what next step to follow. Now, on top of that, being in knowledge-based mode, trying to get to the root cause of the failure is difficult as the user may incorrectly think that, he or she may have entered the wrong code, or maybe there was a system communication lag without getting to identify the actual problem, which then stays latent and is actually the fact that there's no instruction that says which way to turn the knob or handle. As you can see, once we get that notification indicating successful authorization, it's like, what do I do next? Or do I need to turn the knob? What is the function of this? And even if I have to turn the knob, which way do I turn it? Let's take a look at the bottom right picture where we propose a practical solution where we leverage either or both of the designs that conform to the tool we are using and the interface we are interacting with. So first up is the tool-oriented design where the door handle or the knob, whatever you want to call it, mimics the real door handle design, following an ecological interface design approach, making it laterally oriented with the downwards action of the door handle, unlocking the secondary lock versus what we have right now, like the current vertical orientation that doesn't clarify which way we should turn to unlock the door. Second, we follow the interface design where arrows or sideways directed movement indicating clockwise or anti-clockwise can leverage affordances and facilitate task completion. So it could be like a permanent arrow that we have here on the screen, but then that is something that we discussed in class, that we want the design to be intuitive and not something where we have to make it, permanently, like it's like the example that we had, like pushing the door, but then it's written push in alphabets. So maybe we have something like a kind of like a digital GIF kind of a thing where it shows the movement. Coming to the second problem, this one is also interesting. So the top left slide presents a scenario where guest enters the code manually on the touchpad of the physical smart lock. Now, if there is a significant pause in time between entering the digit or if the input is wrong, the user has to repeat the steps. I mean, worse, what could happen is that he has to re-enter the digit if the exact pressure of the fingertip is off. Now, this is cumbersome and security-wise risky, as others could easily follow the pattern entered on the screen facing the users and to others as well. To solve for this precise placement of fingertips and tangibly visualize time while providing security from prying eyes, so first what we did was we added a dent or a bump for precise placement of fingertip. In this particular picture, I've incorporated a dent in this, and there is a digital time progress ring in accordance to the shape of the dial, which will show exactly how much time is left before the user has to kind of mandatorily enter the second digit. And also what is not shown here is basically use some sort of advanced fiberglass material for the touchscreen that restricts visibility to a certain field of vision, which is, it's not illustrated here, but it is kind of self-understandable. And this is our sky's the limit solution to problem one. And just to describe problem one, basically what happens is users find it time consuming and annoying in their decision making of choosing a method when presented with multiple unlocking modes every time they need to enter a premises. So, what would you have done? Like if you were represented with multiple unlocking options, like you could probably use a mobile application or you could use a door code access. And remember, like the visitor's mind would be occupied with how they're going to enjoy the party or the get together in a few minutes rather than spending that time thinking about which method would be the most efficient to unlock the door or gain access. Now, our solution is a recommendation system based on triggered inputs. Now, these triggered inputs could be the time of the day that indicates whether it's day or night. Basically, we are trying to gauge the visibility, or some other intelligent input like detecting multiple voices or background noises. And yeah, listening to that. And we can collect this data from maybe the inbuilt weather app data to figure whether it's daytime or nighttime. And yeah, I mean, that's how it is. Now, this would mean a revised flow. So the user will take out the mobile phone app and wonder which method to choose. Now, once the application is opened, the user is recommended the best option depending on the environmental factors, which happens because the app senses the environment, for lack of a better word. So now the app sends notifications that, okay, you can, I mean, it kind of recommends that you can proceed with option one or option two. And what is interesting is that the user is the ultimate decision maker. Alternatively, we thought of this scenario where what if the user hasn't taken out his mobile phone, but is already at the moment contemplating the two methods? Based on the GPS signal, which kind of we have to assume that the current location on the mobile app mobile should be on, the user will receive an automated voice message that recommends the method suitable for that particular trigger input. Now, for this, the user has to communicate the destination location in the mobile application beforehand so that the app starts sensing when the user is at the host premises. So that was a lot to unpack. Now, if you have made it this far in this video, let's not bore you with our own thoughts and opinions, but let's pass this investigation bug to you listening to us and share us your thoughts. Like, would you prefer a smart keyless entry or a more conventional keyed one? So, well, we three have unanimously decided that a smart keyless system is a way forward because, it's like very trendy and somehow this is something that has to be widely popular and adopted everywhere. Like, I think what is kind of limiting it is the trust has to be earned and given by both the human agent and the machine following a more ecological interface design. And yeah, I mean, it has to be intuitive. So I think, yeah, I mean, I would probably go with smart locks, but would probably want the design to be more ecologically sound. So that's it, folks. And yeah, I mean, let us know your thoughts in the comment section or the discussion board. Thank you.